Alright, sorry about that, guys. My internet decided to drop out for a long time just then. Just do check the live chat, make sure we're back up and running. Oh no, I lost all the messages. Yeah, apologies guys, my internet decided to cut out for a fucking long time just then. So I didn't get to see all of your messages. So I know there was a question about biasing class AB amplifiers. Take an oscilloscope, take a frequency generator, play 18 to 20 kilohertz depending on how nice you want this amplifier to sound, and then what you need to do is run the amplifier through a static dummy load on its lowest rated impedance. So if it's a 4 ohm amplifier or a 2 ohm amplifier, so if it's 2 ohm per channel, then put a 2 ohm dummy load on each channel. Then you need to take the frequency generator, play like 18 kilohertz test tone, and turn it up a little bit, scope the output from the speaker terminals, and turn the biasing knob up until there'll be a little notch in the middle of the sine wave. So you turn the biasing knob up until the notch basically disappears. As you start to turn the biasing pot up, you'll notice that when you start making the notch disappear, the amplifier starts drawing some current and the output transistors start getting hot. So there's a balancing point between when the amplifier is happy running on idle and the transistors aren't getting too hot, but also to a point where the sine wave actually sounds quite clean. Okay, wow, holy shit, we've got very different batch FETs here in the power supply. Okay guys, so I want to check this out. We still make amps using welding stations. Yeah, for sure you can do. That's pretty funny. I have some good IGBTs stuck in a pink heatsink pad and cannot unstick them. Any ideas? Can you heat up the pad? Maybe use a scalpel or something? So this is the power supply for this amplifier that went down. As you can see here, we've got some pretty exploded FETs looking there. Now what's interesting is that I don't think this amplifier's ever been repaired before. It didn't look like it had, but maybe it has. We actually have some FETs here, which are from one bank, one kind of manufacturer. But then we've got some others here that are completely different. They're not even from the same factory by the looks of things. They're completely different entirely, and they're actually being ran in the same parallel bank, which is not healthy whatsoever. So what killed this amplifier was either that small piece of wire that was floating around inside, or it was the fact that these FETs were not properly matched and just died of their own accord. Yeah, because they weren't very happy, of course. So what I'm going to start doing is I'm going to start removing these FETs just now. Yeah, screw it. We might as well just cut these off. Actually, what might be quick? It might be quicker to take them out individually, actually. Why can't the amp protector protect its MOSFETs? Well, it can't. The amp protection circuit can't protect the power supply MOSFETs really, because the power supply MOSFETs are being fed with constant power from the battery terminals. So if something happens to one of the power supply MOSFETs and it shorts, then the protection circuit is only going to notice it when it's happened. And once it's happened, it's too late. The FET is already shorted, and that FET being short is going to smoke up and kill a lot of other stuff on the board. The output section, however, the output section protection does usually work, and it does often work. Sometimes it doesn't, sometimes it does. Sometimes it's not quick enough to catch the fault if the speaker terminals have been shorted out and the FET explodes. It's also not capable of catching issues where a FET spontaneously explodes, but it will usually protect the rest of them, and also the output section protection circuit usually protects the power supply, but not every time. It's one of those things where it might protect it, but it's not a guaranteed thing. Have you listened or repaired JBL 6000 GTI crown amps? No, I haven't, but I really would love one. Yes, they are fucking amazing amplifiers, even to this day. I would love one of those great big JBL crown amplifiers. They're stunning pieces of engineering. I would very, very much like one of those things for sure. Heat gun only burnt the bench. Maybe try water. Maybe try submerging them in water. Perhaps it's difficult because it's difficult about like what is sticking them on there. Is it the airtight seal, which heat should have helped out with, because the air then expands. If it's not an airtight seal, if it's just the stickiness of the pad, then perhaps water will help. Yeah, tough one that to really know. But surely, if you don't care about keeping the thermal pad, surely just taking a standing knife and just prying in between the FET and the silicon pad, surely the silicon pad would come off eventually. You just scrape it off. I'm just applying some fresh solder here to these pads so that they come off much easier. Fresh solder contains flux, which helps this stuff to flow, and helps the FETs come out nice and easily. Try and do this nice and quick. So I won't actually be able to do a full repair to bench testing on this amplifier today, because I don't have enough. I don't think I have enough 3205 MOSFETs. Unless they've come in the post today whilst I've been in the workshop. Does voltage drop in the input below the power supply? Not usually, no. So people are really like convinced, you know, they're like really uptight on, oh, you got to feed your amplifier good electrical, and you've got to feed your amplifier good electrical to make it do its rated power without clipping. The problem that people have when they run their amplifier to like 10 volts is not so much the strain. You don't really put any strain on the amplifier as such, provided it's clean. So the only time when you're going to kill your amplifier running it with 10 volts worth of input is if the output is heavily clipped. because you're asking the amplifier to do more power at a lower voltage, and the current handling is going to be limited. If you run your amplifier down to 10 volts but the output is relatively clean, it can be clipped a little bit, then you shouldn't have any problems. Running the amplifier at 10 volts doesn't automatically damage it at all. I run these amps at 9 volts in the workshop during repair because it's much safer. It's much lower voltage on the output section, much slower for these things to explode on 9 volts. So yeah, running this thing at lower voltage doesn't actually stress the amplifier at all. In fact, the amplifier is actually slightly happier running at a lower input voltage because everything's under less stress. It's further away from its saturation voltage. The problem comes when you try and draw a huge amount of current from the amplifier with a low voltage input, like 9, 10, 11 volts, because the amplifier will still try and provide a lot of current, but because you've got a lower voltage there, the current is higher than it would be with the same power if the voltage was higher. So provided you aren't clipping your amplifier, low voltage input isn't a problem. It just means that you don't get as much power. People don't often realize that actually car amplifiers, they don't make power, they just convert it from your batteries and from your alternator. So you can only give your sub as much power as your batteries and alternator can provide. You can't give the sub any more than that. So if you've got a stock electrical system and you buy a 10k amp, the sub is never going to get 10k, ever. Because your electrical system can't provide it. So was it going to make power out of thin air? No. You can only convert what you've got, and the conversion rate is pretty shitty at about 70 or 75% for modern Class D amplifiers. So you're only not even getting what your power supply, what your batteries and alternator can provide. You're only getting like 70% of that. Maybe even less at 1 ohm or 0.5 ohm. It's even less at 0.5. So you can only get from your supply a percentage of what your supply can provide. Did you give your opinion on these DC 5K amps? I missed the start. Yeah, they're a 15 or 20-year-old circuit design, so they're nothing special by any means. They're very generic. They're the same circuit design as so many other shit out there. However, because it is a very old circuit design, it's had most of the bugs and the flaws ironed out by now, and the build quality of this one is pretty good. So it's not going to really get damaged by vibration very much. It's all been assembled very well. So because it's a very old circuit design, it's pretty reliable, it's beefed up, and it's actually not a bad amplifier at all. This is probably one of the most reliable circuit designs and amplifiers that you can get. The only one niggle that I have with it is that the output section uses IRS21844S drive ICs for the output MOSFETs. And they get very hot. The drive ICs, they run really warm. And because they run quite hot, they do have quite a high failure rate after a certain amount of time. Almost like a ticking time bomb. So the way to make that more reliable would be to simply put some small heat sinks on the chips, which wouldn't really take much to do at any of the factories, but they don't never bother doing it really. A couple of these amplifiers do come with heat sinks on the chips. Soundstream amplifiers I have seen do have heat sinks on the chips, as do a few other brands that have this circuit design. And those are generally more reliable as a result because the chips don't overheat and short out, killing the output section and taking the power supply down with it. But yeah, they're generally pretty good. My question got lost. I got a Diamond 1500 on the bench. Plays fine, but the output FETs get super hot and shut it down after about 5 minutes. Oversee that. Diamond 1500 plays fine, but output FETs get super hot. So do the output FETs get super hot when the amplifier is idling, or do they only get super hot when you are running power through it? If the FETs get hot when it's idling, then that is not good. That is not good. That means that you have problems somewhere that you need to resolve in order to get the amplifier working. These Class D amplifiers, generally when they're idling, the FETs should not get hot at all. Some of the new Class D amplifiers, because they're using such high input capacitance FETs, the output FETs can reach like 35, 38, 40 degrees on idle. That's fine. But if the FETs, when they're idling, are getting over 50 degrees, then you have a problem. Making sure that I don't have any solder bridges here, because we're going to have to do repair to the drive circuit and we're going to have to test it out in a sec. Okay, so just an update on this one that I'm working on. All the power supply FETs, I've just removed them from the board because we're going to load this up with a whole fresh load of power supply FETs, sorry. But also, I don't know if you can see here, but on the back of the board you can see that the drive circuit has been pretty badly hit here. Here we go. So these little sections here on the opposite side of the board are the drive transistors, and as you can see, there's a lot of heat marks on the board from where they've got very, very hot. Now hopefully they haven't carbonized the board, because when that happens you have to drill a hole in the board and wire it up manually. So this section of drive transistors got pretty hot, as did this section. You can see here there's more heating going on here. So because these got really hot, it's good practice to replace all of them. So we have, if we turn the board over, we can see how many we have and what we need to replace. So we have the drive transistors here, we've got 8. There'll be 4 PNPs and 4 NPNs. And these are classically A1275s and C3228s. I'm going to load them up with something slightly better. I'm going to load them up with BD139 and B772. They're just a lot better, a lot quicker, a lot higher current handling, etc. And you can see here, if you missed earlier on the stream, I showed you one drive transistor that was very visually damaged. This one's obviously got very hot and blown the casing of the transistor. So yeah, all these need to go bye-bye. And I think the easiest way to get these out, they're a bit of a pain in the arse to remove from the board normally, because you have to grab them from underneath. The easiest way to remove these might actually be to just snap them off the board and then remove the legs individually. So that's what I'm going to do. We don't need these bad boys anymore, so let's snap these off the board and remove the legs individually with our soldering iron. It would be cool to have some 24, 36 volt systems, much less copper to waste. Like, as in like vehicle systems, like, so if your car alternator and batteries were running at a much higher voltage. Yes, I agree. So lorry and trucks are generally 24 volts. Yeah, some of the new hybrid cars I think might even be a higher voltage than that. It makes more sense. But I get it. I get why you wouldn't want to have high voltage in a car. It becomes a bit dangerous in terms of a fire hazard, and also when you know, if you crash the car, if there's an accident, you don't want high voltage floating around. If you've got batteries that have high voltage in them, you don't want to be getting a shock when something shorts out during an accident or anything like that. So I get why you have low voltage in a car. But from an electrical point of view, it would be better to have a higher voltage, because then there's less current and there's less voltage drop between the different components in the vehicle. Okay, cool. So that's all the little transistors removed. So now we're going to take our soldering iron and we're going to use our tweezers to remove all the dead legs there. These are actually a pain in the arse because they're actually bent from the bottom. So what I'm going to do, just to make life easier, is I'm going to use a soldering iron to melt the solder and push them down to the underside of the board. like this. And then what I'm going to do is I'm going to flip the board over and pull them out using the excess from under the board. Snapping the leg off at the top also works, because then it means it doesn't try and pull it through at an angle from underneath and prevent it from coming through. Then we've just got the little bit excess left on the bottom. This one's being a bit of a pain in the arse though, isn't it? There we go. Cool, so now let's flip the board over, remove those legs, and before we fit new drive transistors, I do want to just make sure that the TL494 chip survive. The TL494 chip is the chip which is responsible for giving the drive waves to these drive transistors, which then go to the MOSFETs. Usually that chip is always fine, it never dies, that chip, so we should be fine on that. Gotcha. What temperature are you using on the soldering iron? About 400 degrees. But this is an AOUA soldering station, so it's not particularly accurate. So I don't really know what temperature the soldering tip is. I just know what it says on the station, which probably isn't accurate. I just know that this temperature is good for doing this, which is all that matters. Some of these I'm going to push down and get from the other side because there's something catching on the other side. It's not letting them be pulled out. So I'll get them from the other side. I'll straighten them up this side and get them back from the other side again. Most of these are coming out really quick though. Yeah, the board did actually get slightly damaged from the heat here. As you can see, there's lots of sort of black, darker areas around this circuit. So yeah, this did actually get hit by the heat of these transistors dying. Cool. So all the legs are out. Which is your favourite MOSFET? 69N25 is my favourite MOSFET. I don't know why. I really like that MOSFET. It's driven extremely well. It stays super cool. It's a high current MOSFET that works in lots of 3K and 2.5K amplifiers, even up to 4K sometimes. Yeah, it's just a really nice little, really nicely balanced MOSFET. Did you ever blow an amp while testing? Yeah, all the time. No, not all the time. Probably a handful of times. But yes, it does happen. You know, you repair an amplifier to what you think is repaired, but there's actually still a problem with it that you haven't seen or you haven't noticed, and then obviously while testing it blows up. So yeah, it does happen. The Sundown Audio 6K that I repaired recently on my live stream, that one actually exploded during some endurance idle testing at 14 volts. But I know the reason that blew up, and that was because the FETs which I had fitted, we had actually been, because we've been doing the live stream, what I didn't realise is I'd been slowly damaging those FETs whilst we were doing the live stream and whilst I was showing you what the issue was. So every time the amplifier drained its rail caps through the FETs, it was slowly killing them and preventing them from being able to run with the 14 volt input. And so then when I did put the 14 volt input on them, the FETs exploded in my face and was very, very scary. But the repair that we made on live stream was solid. That was the issue causing the amp to give the issue. It's just that obviously the issue that was happening with the amp was slowly killing the FETs that I had just fitted. It's kind of annoying. Yeah, that Sundown was super annoying. Oh no, sorry, not the Sundown. Sorry, the Ground Zero the other night. The Sundown did blow again now actually, but it wasn't during my testing. It was when it was in the customer's car. Yeah, not entirely sure why, but yeah, I repaired it again. I rarely get things come back, but obviously you always get one or two, and it can either be something that you've missed as the tech, or it can be something the customer did. It's one of those things really. If you're doing amp repairs like as a business all day like this, then yeah, you know, you're gonna get one or two things come back occasionally. But it's quite rare. I rarely get stuff come back. It's very rare that I get something come back. And when I do, it's always like, oh wow, what the hell? What? So, you know, it's always kind of annoying, but also kind of exciting, because then I get to learn, like, okay, so why has this gone down again? I speak to the customer about what he was doing with the amplifier when it went down, try and work out if it was a customer fault or whether it was something to do with the repair or whether it was something that I missed, etc., etc. It's always interesting, but it's very rare. I think I've only had 3 amps come back, 3 or maybe 4, but one of them was a customer's fault. I think I've only had 3 amps come back that was either something that I missed or a part that we fitted that turned out to be not compatible or something like that. Out of all the amplifiers that I've ever repaired, I'm quite thorough. I don't like to, you know, to give the customer back something if I'm not absolutely 100% sure that the repair is as solid as it can be and that we haven't missed anything. But you know, yeah, it does happen sometimes. Okay, cool. So that is finally all of those holes for the drive transistor location sucked out, so that all the legs are now gone. Let's put these into the bin here. Do you keep stock backup components? Yes, I have a massive stock of components here. I have a drawer full of all sorts of bits and pieces for all sorts of amplifiers, and I also have more bits over there, and yeah, I have a few bits laying around. Hello to Scott from Texas. I was in Texas, I was in Dallas not too long ago, so how's it going? It's pretty nice out there. How many years have you been repairing car amps? 1.5. 1.5 years. Okie dokie. So now we get to the fun bit where we put power into the amplifier and we see whether there are any drive waves anywhere from the TL494. TL494 is this chip which is situated on this driver board. This is actually a KA7500C, but it's the same as the 494. They're just different names. So the TL494 or the 7500 is what generates the PWM switching wave for the power supply. So this chip here should be sending square waves to these drive transistor locations here and here, which then pass it on to the MOSFETs over here. So just before we turn the amplifier on, I'm going to go ahead and make sure that there aren't any solder bridges between any of these pads, because this is 12 volts and it's going to be sending to the drive. I'll clean the board up in a bit when we fit the MOSFETs, get rid of that black and stuff. We've also got some blown gate resistors we need to replace as well. I just want to check the drive circuit first, so let's just make sure that there are no solder bridges along here. Looking good so far. Make sure there's none on the bottom. Very important to check yourself for solder bridges. I make that mistake far too often, really, considering I forget to check for solder bridges. Sometimes it happens. There we go. Spin the board around. I hate this wire for my head cam. I'd love a wireless head cam, that'd be sweet. Okay, now we're going to put some power. So, let's take the power wires, temporarily shove them in here, because we don't need any current whatsoever. The amp will draw less than 0.1 of an amp to power up the 494, provided everything is working okay. There we go. Okay, so you can see up in the corner of my screen there, we've got the current and the voltage, so let's turn her on. So we've got 12.4 volts and 0 amps, which is good. If we take our oscilloscope probe, then we just need to confirm that we do have 12 volts on the drain of the power supply MOSFETs, which we do. Turn that up a little bit so we can see that on the scope better. There we are. So we have our 12 volts there. So now what we want to do is we want to go ahead and check to see that we have the square waves on the driver board locations, which is in here. I think I might be able to show you that on here. If I go in here, smooth over just a touch to the camera. Try and get that on the camera for you. Damn, why is it so far out? Okay. There we go. So yeah, we should see some square waves here from the TL494. So let's apply some power and make sure that we do. I'm only going to allow 1 amp to pass from the power supply. Very, very low current. There we are. Cool. So we have some nice, sexy looking square waves here, and they should be on pin number 3. Or pad number 3 of all of these driver transistor locations. So just want to make sure that the square wave looks the same on all of these. Looking good so far. And we're going to go ahead and check the other side of the board over here. Make sure that this is the same over this side. Yeah, looks pretty nice. Cool, so we have good drive from the TL494. That's the first thing that we need to check with power. Now we turn the power off, we take some new drive transistors. Now I'm going to be replacing those original drive transistors with some slightly better ones. BD139 is the NPN and B772 is the PNP. So the 139 is the PNP and those two go in the middle, because I made a note of that when we took them out. The NPN replaces the C marked transistor and the PNP replaces the A marked transistor. So I'm going to take my 139s from in this drawer, I'm going to load them up into the old C transistor location on the board. Some of these holes are tighter than others. Yeah, my trousers are absolutely covered in thermal paste. Thermal paste gets everywhere when you're repairing car amplifiers. You gotta learn to accept your fate. If you're gonna be doing car amplifier repair, then you're going to be covered in thermal paste the majority of the time. It's just one of those things. Sup from Colorado Springs. Supposed to be working, but this is more important, says Jordan. Cheers, buddy. Thank you. I'm glad that the repair is more important, but probably not. Let me know what it is you do for work in Colorado Springs. Slowly running out of these. I use these a lot. These are probably one of my most used component. Is these drive transistors, these BD139s and B772s. They do get used up pretty damn quick. And I think I order enough of them to last me a year, and they last me a few weeks. Love your channel and just saw Nostalgia Noisia. Just saw Noisia last Sunday at Red Rocks. I heard you listen to Noisia Radio on the other vids. Yes, fuck it. I absolutely love Noisia. I love Noisia Radio. I listen to pretty much every Noisia Radio as it gets released. So I'm super jealous, my friend. That must have been a fantastic thing to see. Super jealous. I did see Noisia one time in the UK, but the set wasn't... It was okay, but it wasn't amazing. Okay, one more transistor to go, and then we can push them in and solder from the bottom. Oops. One of these holes actually needs to be sucked a bit more by the looks of it. Ah, there we go. Okay, cool. That's her loaded up with new drive transistors. So let's go ahead and solder those in from the bottom. Just got the diamond D3 1100.1 hooked back up, and yep, the outputs get instant hot at idle with no signal, no output load. So that means that you have a bad drive, most likely, to the MOSFET. So you need to check. You need to crack open your scope. You need to get your scope out and find out what's going on with the drive waves going to those FETs. So get your scope out and look and see what the low side drive wave looks like to the low side FETs on the gate, and it should be a nice square wave. If it's not a nice, I mean, it doesn't have to be a perfect square wave. The low side drive rarely is a nice looking square wave, but it's got to turn it on quickly and turn it off quickly. If it looks really shitty, then it's probably that's the problem. Send me a picture of what the low side drive wave looks like to my Bearvids Facebook page, and I'll tell you whether it's a good looking drive wave or a bad looking drive wave. Trying to get my zoom in camera just angled a little bit here. Oh, look at that! Perfect. I just moved the camera and it was actually bang on where I wanted it to go. Perfect. Right, let's take our soldering iron. I'm actually going to change my tip over to the smaller tip. To do this is much easier with the smaller tip. So let's remove the large tip here, and let's put in our thin tip for doing intricate work with these legs here. There's so many innuendos in this video. Hi Speaker Freak. Didn't miss much. Basic power supply failure on a DC 5K. Doesn't seem to be any output section failure though, so we are either blaming the power supply failure on mismatched power supply FETs which we found in the board, or there was a piece of wire loose floating around inside the amplifier which could have shorted something out in the power supply drive. This tip's really good for SMD stuff. If you don't want to use the hot air station, or you need to top up the solder after you've used the hot air rework station, this tip is really useful for all sorts of bits and pieces. Wait, that tip is tiny. That's another innuendo. There's so much innuendos going around today. Do you have a cat? No, I wish I had a cat. I'm actually pretty allergic. I could probably get a cat that doesn't make me die, but yeah, I'm actually pretty unfortunately allergic to cats and dogs and other furry creatures as well. Super annoying. Because I love kitty cats. What do you think about rebased music like DJ Rusticles? Naked cats, I'm not that fond of how they look. I want a kitty cat with lots of fur that I can stroke, and it's super soft, squishy cat. DJ Rusticles and all the rebased music, yeah, like I support the stuff. It's fine. I did some rebased music, BP rebase. As long as it's clean, it's fine. I don't think that there are any other. I mean, I don't want to blow my own trumpet here, but I don't think there are any other rebase music artists that were doing quite the same stuff that I was doing, in the sense of rewriting a legitimately musically accurate bass line that followed the original thing of the song, and that, you know, the bass line actually had progression and it changed between verses, and the chorus was different, and all sorts of other bits and pieces like that. The bass lines, the rebasses that I was doing, incorporated expression, dynamics, pitch, bend, and all sorts of stuff like that to make it sound really fucking cool, like it was part of the original track. It flowed perfectly with the music, tonality, and flow. I think a lot of the rebasses, they're just using Audacity to whack frequencies that roughly sound about right on top of the original track. So yeah, but the problem is doing it the way I did took much longer, because you're literally writing an additional part of the music, and you're having to do all the pitch bends and expression, dynamics, modulation, all that sort of stuff. It did take much longer, which is one of the reasons I kind of stopped doing it. But I also stopped doing it because my computer actually died, and I lost all the software, and I just never bothered getting it back. I currently have two MMATs 3500.1 amps on TFI Audio SP415s. I'm looking to sell them. Just get one HCCA 5K V2. Well, no. There'll be a difference then in how you run it. So you need to tell me what voice coil are your FI Audio SP4s, because if they are dual 4s or dual 2s, then it changes how you use them. So if they're dual 2s, then each amp will see 1 ohm at the moment, which means that your Orion amp would then be ran at 0.5, which might be okay. The FI SP4, I think that's a relatively high inductance woofer. It will depend on your box design and how they're being run in the enclosure as to whether the amp will be happy at 0.5. Thanks, Jordan. I appreciate the kind words there. Yeah, the walking in the air was a good one of my favourite ones. I also, my absolute favourite, and I play it all the time, is the Naruto Sadness and Sorrow rebass. Like, the bass line in that, because the track doesn't originally have a bass line as such, I was able to write in a bass line that sounded really like it was meant to be there already. Beautiful, really, really lovely bass line that we put on that track. So I'm very, very happy with that one. Are you using leaded solder? Yes, of course. Lead-free solder is like fucking cheese. It's like trying to solder with Philadelphia or something. Okay, so that's the drive transistors in place nicely. So what I can do now is I can spin this back over, clean off under the desk a little bit. We can put the power back into the board just now, and I can actually just make sure that those drive transistors are happy and working. They should be. There should be no reason why they shouldn't. let's go ahead and power this baby up. Make sure that we have drive waves on the power supply section. Now the power supply section, the FET area, we still do need to replace the gate resistors, but that takes ages, so I probably won't do that today. Well, I'll do it in a minute, but I won't do it on live stream because it takes fucking ages. So if we look at the board just now, we have got, again, just put the glasses on and the camera's into focus. We've got the new drive transistors in here with the same lead pitch and everything, so that's all perfect. TL494 works. That will be sending the drive waves to these transistors. This then gives them to all of these pads over here on the gates, and as I said just a moment ago, lots of these resistors look pretty burnt out, so we'll be replacing those. But for testing purposes, we don't need to load up all of these FET locations. You can see here that we've got 8 transformers here. So each transformer needs a push and a pull FET. So per each transformer, we only need 2 FETs. So by the looks of things over here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 FETs along each side, and we've got 4 of these. So by the looks of things, each transformer has 4 FETs. So you got these 4 FETs will deal with this transformer. These 4 will do this one. These 4 will do this one, and these 4 will do this one. And you will have one that pushes and one that pulls. So this little pair of MOSFETs here, these will be in parallel. So we only need to put one here and one here. One push and one pull. One push, one pull. So we need 1, 2, 3, 4, 5, 6, 7, 8. We need 8 MOSFETs per side to get the amplifier up and running, to make sure the output section works and to make sure that this is going to be a successful repair. Once we've done that, we can go ahead and load it up with all the power supply FETs, and then it's fixed. At the moment, unfortunately, I can't do that because I don't have enough 3205s. I have ordered like 200 3205s, but they haven't come in the post yet. So just to prove that this amplifier is a working, fully functional repair, I can take some 3205s that are still working, and load them up in the amplifier here. And like I said, I need 8 per side, and that'll show whether it works or not. Can I find your rebases anywhere? Yeah, I've got them on Google Drive. If you message me on my Bearvids Facebook page and say, yo, Bearvids, can you send me your BP rebase folder? Then I'll send you a link to the Google Drive with all of them on there. Okay, so all of these are pretty much dead. Let's take some of these ones in. Are you still distributed for DD? I enjoyed the small woofers you were showing. Something about such a small woofer flex so satisfying. Yes, I am still doing DD in the UK. And if you saw my most recent video where I went over to Oklahoma and did a factory tour, a build house tour with DD, yeah, so I'm still working very closely with Digital Designs, doing a few bits and pieces for them. I sent you a video about my audio pipe with the rail cap. Want to charge, but the fault light is on while the blue light keeps flashing, and the output section was out, so I replace all 8 of the 640Ns on one side of the channel, and I check the BIOS resistors along with the gate transistor, and I have not found the problem at this point in time. So the problem, you need to change the drive transistors as well. So on those audio pipe amplifiers, you will have there's 6 transistors, tiny surface mount transistors, and they're marked with 2T and 2X. You need to change those ones along the output section for the thing to be repaired properly. So I need to actually find 16 FETs 3205s that work. For this quick test, I don't need them to match. They can be unmatched and get a little bit warm. It doesn't matter because I'm going to take them off straight away anyway. But I need 16 FETs that are the same FET that work, that aren't dead. So I've got 3 so far. So this is how low I am on 3205s. Fucked. That's 5. That one's dead. This one has shit tons of solder on the leg, so I can't get in there, get measured. That's dead as well. Right, 1, 2, 3, 4, 5, 6, 7, 8. So we're halfway there to finding 8, 16 that work. Anyone heard of Lab Gruppen amps? I think that name does ring a bell. I feel like I have kind of heard that name before, but I don't know where or don't know anything around that. I have heard that name before, yes. I'm not sure that we're going to have enough that actually work. What the fuck? I need 4 more, so maybe we will have enough. Right, 1 more. There we go. Right, there's our 16. Are they all actually 3205s and I'm not put some in the wrong drawer? Yep. Yeah, 805, yeah. Okay, so they're all completely different batches, but it doesn't matter for this very, very quick test, just to make sure the output section works. We just need some FETs in there to load up to get this thing up and running with the rail voltages. So once this is done, the new FETs will arrive tomorrow, and then we can complete the repair, reassemble, and it goes back to the customer, provided it's all good. So we don't need to solder the FETs in properly through the holes. We just need to just lay them on top. We can lay them on top here and just solder from the top of the board, just to connect the legs to the pads here very briefly for this very quick test. There you go, that's one. And then we put the other one. I'm going to try and choose ones that where the gate resistor isn't quite as fucked as, because obviously if we've got a fucked gate resistor then it's not going to work. But I'll replace the gate resistors when it comes to replacing the rest of the FETs properly. I just want to see that. I just want to see it come on. I just want to see the output section work. 1, 2, 3, 4. Lamb. I'm actually going to deliberately put solder across all 3 legs here because there's a fucking massive solder here, and I'm going to use my desoldering braid to get rid of that excess solder there in a second. There we go. Now the other side. Big hello from the East Coast Canada. What's going on? We're almost at the end of this initial repair on this DC 5K. We're just doing the last little test now to make sure the output section hasn't blown as well. It was a power supply failure on this one, and it was power supply FETs, gate resistors, drive transistors. That was the 3 things that were replaced in this repair so far. So I'm just loading up some temporary new FETs to the output section. To the power supply section. Very temporary. Just to get the thing up and running, just to see whether it's going to work on the output section. If the output section works, then we'll wrap it up and I'll fit brand new fresh set of MOSFETs on the power supply section tomorrow when they arrive in the post. Alright, cool. 16 temporary MOSFETs load up to the power supply section. Make sure that they're all good. I'm also just going to make sure that the gate resistors on these temporary ones that I've loaded up are roughly 47 ohms. They don't have to be, they can be a bit out of tolerance just for this quick test. But just going to make sure that we have roughly 47 ohms on these gate resistors here. So yeah, 46, 47, 46, 47 is fine. 46. See, this resistor looks pretty badly burnt, but it's actually still within tolerance, but obviously we will change it because it won't be able to pass as much current anymore. But it actually is still within tolerance there. 47. 46. 46. 47. 46. Oops, wrong side. 46. Interestingly, this one's actually gone down in resistance. That one's 39. That's curious. Usually they go up in resistance when they blow. I'm just going to move this MOSFET to the pad next to it because the pad next to it has it's actually closer to the original value of the resistor that it should be. Then it takes me a couple of seconds. So move that over. So might as well do it. There we go. Looks like there was one with a solder bridge on it. It's possible. I'll check for solder bridges in a moment. So let's go for this one's all going to be correct. Yeah, that's all looking good. 46. Okay, cool. So now we check for solder bridges. So we put our probes over here. If there is a solder bridge between the drain and source, then there'll be a short circuit, which there's not. Check for solder bridges on the gates. If there is continuity between the gate and the drain, then there will be a beep. No solder bridges. That's good. So, cool. Let's apply some power, and then this amplifier should come fully on now. It should come fully on because we've fitted enough power supply FETs to run the amplifier fully. The output section's all in because that didn't get repaired. That seems to be okay by the looks of things. So yeah, let's go ahead and turn the power supply on and see what happens. So we've got power supply over there, we've got the scope over here. We're going to be probing many different things. I'm going to explain exactly what I'm probing as we go along. So the first thing I want to check is I just want to check that we've got our 12 volts sitting there. Actually, I'm going to turn the voltage down from 12.4 to something much safer for the first power up. That's a bit low. Let's go up a touch. Tiny bit more. That'll do. So we're going to make sure we've got our 9.4 volts sitting there waiting. We have. So what we're going to do is I'm just going to pulse the power supply one time. I'm going to touch the remote with my foot pedal. I'm going to pulse the power supply one time just to start the rails building so I can probe the output section to see what we've got over there. So let's probe the power supply. Let's see the one pulse of power supply. There we go. See that tiny little pulse. Now I'm going to go ahead and see what's going on the output section. So we've got the high side, which should have positive rail, which it does on these two. And then the low side should have nothing. And then the high side should have positive, that's correct. Same on the other side, we should have high side with positive rail, low side with nothing. That's correct, low side with nothing, high side with positive. That's looking good. So now what I can do is I can go ahead and give this more power for longer. Let's turn the current up. So I've got 1.5 amps. So let's give it 4 amps and let's see the thing come fully to life. .25 volts on the output. Let's go down a bit. Okay, the output section is switching. You can see there the switching waves. So the output section is working beautifully fine. We've got 2.9 amps worth of current draw on there. So now we had that turned on for about 5 seconds just now. So 5 seconds will have been long enough for any of the power supply FETs to be heating up a lot if there was a problem with the power supply. So let's go ahead and take a look on our thermal imaging camera. All of these FETs are staying very, very stone cold, which is nice. If we go along over here, there's a bit of heat over this side perhaps. Or no, it's just because the floor is very cold in comparison. Let me feel it with my hands. No, nice. All the power supply FETs are staying very, very cold. So let's turn the amplifier on once more and check all the drive waves for the power supply. Each FET we're going to check the drive wave of. Let's go over here and zoom in and touch more. So these are all going to have slightly different shapes because they're all different FET batches. Is not ideal. So we just want to make sure that they're all being driven properly, which looks like they are. 2.9 amps is about right for this amplifier. Cool, power off. Check for heat on the FETs with our hands. Can't bother to get the thermal imaging camera out again. Despite these FETs all being completely different batches from one another, they're actually staying stone cold, which is quite surprising. So they're all obviously of a very similar VT. And yeah, VT would be the only thing that would affect this. The gate capacitance is so low that it wouldn't really affect it, even if there's a difference. So yeah, these different batches of 3205 obviously all seem to have pretty similar VT rating. So yeah, and that is a repair. The only thing I've got to do next is just to fit the rest of the power supply FETs. So I'll have to take all these out again and then load the amplifier up with the same batch of 3205, which should be coming in the post tomorrow. Once that's done, it goes back in the case, do some bench testing and do some endurance testing, and yeah, then it's good to go back to the customer. Oh poop, I figured out why I couldn't find the drive circuit on this diamond amp. It's encased in plastic. It looks like a big film capacitor. I took a driver board and potted it into a case. That's really annoying. Crazy Logic, yes. Some of these amplifiers, the drive circuit is completely doused in epoxy. And it makes for repair work on those driver boards a fucking nightmare. I do not envy you.